Okay, today we're going to be working on experimental probability. Experimental probability is an estimate of the probability of an event. It is called experimental because you get to make observations and conduct experiments to find the number of times a certain event actually happens. So most students like experimental probability because they are conducting an experiment. So with experimental probability, you find it when you are conducting your experiment by taking the number of times the event occurs and dividing it by the number of trials. So for example, if you take a coin and you toss it 10 times, a head is recorded 7 times and a tail is recorded 3 times. So in this problem, P is standing for probability, so the probability of you getting heads would be 7 out of 10 tosses. The probability of you getting tails is 3 out of 10. Let's take a look at a couple of examples here. So with experimental probability, like I said, you are conducting an experiment. Suppose you have 12 marbles. Without replacing any marbles after your selection, that just means that you're not going to put the marbles back in the container, you pull a red marble 5 times. What is the probability? What is the experimental probability of getting another red marble the next time you pull a marble? So the probability that the marble is red, number of red marbles divided by the number of marbles in the container, and that's 5 out of 12. So the probability of getting red on the next selection is 5 out of 12. Example 2, let's say you have a softball practice and Manny had 6 hits out of 15 times at bat. What is the probability that he will get a hit his next time at bat? So again, P is standing for probability. This is what we're actually conducting the experiment on, the number of hits. So we take the number of hits divided by the total number of at-bats, we get 6 out of 15. So whenever you can reduce your fraction or probability, you should. So dividing each by 3, we get 2/5. In the next example, what is the probability that Manny will not get a hit? Now this time we're going to continue to take that same fraction, but we need to deduct it from 1. Now 1 is standing for 100% of the time, so if we deduct the probability of getting a hit, we can get the probability of not getting a hit. So you can see I'm taking 1, subtract that 6/15, I get 9/15, which reduces to 3/5. So remember, both of these should add up to 100%, and it does. 2/5 plus 3/5 is 5/5, or 100%. Remember, when you are subtracting this 6/15 from 1, you can write this as 15/15, and then you can easily subtract it. So 1 is always equal to that number over itself. So if I use 15/15, subtract 6/15, that's how I got my 9/15, and then I just reduced it. In the third example, Pam is playing darts. She hits the bullseye 7 times out of 20 throws. What is the probability that Pam will hit the bullseye on her next throw? So again, we're just taking the number of bullseye hits that she got out of 20 and dividing that. Now I can't reduce that, so I'm just going to leave it alone. Now the probability of her not hitting the bullseye, again, we're going to subtract that 7/20 from 100%. And again, you're going to use that 20/20 this time because that's our denominator to equal that 100%. Subtracting 7/20, and you get 13/20. Okay, so today we're just going to practice our experimental probability using a Kahoot game. So that is also attached on the Google Classroom. So have fun and enjoy.